Okay, Precalculus, here we go with day 2 of trigonometric identities. Just historically, a mean section that people don't really love. According to our author here, to establish, which is a word I've never used for this before, but this is what our author wants to call it, to establish a trigonometric identity, it means to verify, which is what I always called it, verifying trigonometric identities, that both sides of the equation are identical. So you rewrite one side until it is identical to the other side, which we did with one example on day 1 notes. The other side, of course, you don't change. Leave one of them alone and don't change it at all, and change the other side until they're identical. That's the goal here. Now we're going to use the same known identities, the ones that we started with, and the same hints that we worked with yesterday. And there's a couple more tricks out there, but this is where we're going to start. Note, there is not always just one method for verifying. You could substitute, like, if you have a sine squared theta, you could write it 1 minus cosine squared, or you could write it 1 over cosecant squared. There's different ways you could rewrite things, so sometimes there's more than one direction to actually establish these trigonometric identities. Hint number 1, these are just me repeating stuff from yesterday. It frequently helps to rewrite every expression in terms of sine and cosine. Hint number 2, multiply by the conjugate so that you get something squared that usually ends up being followed by the usage of the Pythagorean identity. Turn two fractions into one by getting a common denominator. That happens a lot in these kind of expressions. And hint number 4 is factor and see what cancels or combines in another way. Okay, so I've got 4 examples for you today. Here we go. This came out real small. Sorry about that. It says 1 plus tangent over 1 plus cotangent is equal to tangent. I'm just going to let you stare at that for a second and think of what you would do. Right? Now, here's what I'm going to go with. I could write this type. By the way, a hint, when you pick which side you're going to work on, pick the complicated side. It's real tough to take that and just start rewriting it and turn into that. It's much easier to pick the complicated side. Things tend to show up for you. Oh, sorry. I had to yawn. Now, I could write this as 1 plus sine over cosine and 1 plus cosine over sine, but I'm making things much more complicated with a numerator and denominator in the top and a numerator and denominator in the bottom. So here's what I'm going to do this one. I'm going to write 1 plus tangent x, and then in the bottom I'm going to write 1 plus 1 over tangent x. Instead of changing both to sine and cosine, I'm thinking if I write this cotangent as 1 over tangent, I may be able to get something to cancel here. That's the thought process. Now, in this bottom, in the denominator, I've got a single constant and a fraction. I want common denominators there. Usually, when you have a complex fraction, you have a fraction in the denominator, you're going to want to flip and multiply. So my next step, don't touch the one on the right, just leave it the way it is. I'm going to leave this numerator where it is, and I'm going to write this so that it is 1 denominator. So I'm going to write that 1 as tangent over tangent. I just wrote it over 1 and got a common denominator. Okay, and so I'm going to do a little arrow to go up to the top here. And now what I have is 1 plus tangent of x. I haven't touched that numerator at all. And then in the bottom I have one fraction, and is tangent of x plus 1 over tangent of x. And that's supposed to equal the tangent of x. You can see that these tangents have to cancel somehow, right? I mean, you should be able to see, okay, if I got to end up at tangent, something's got to cancel here. So now that I took these two things, these two terms in the denominator, wrote them as a common denominator, and now I have one fraction in the denominator, I'm going to flip and multiply. So I'll put this in parentheses just so you see what happened. The 1 plus tangent x is now going to be times this fraction flipped. Tangent of x over tangent of x plus 1, and it's supposed to end up equaling tangent of x, and it does. You might not see it right now, but look, I've got a grouping symbol 1 plus tangent of x, and a grouping symbol, a denominator is a grouping symbol, of, isn't that just the same thing, 1 plus tangent of x? So these two cancel, and I have tangent of x on the left side and the tangent of x on the right side. Check. I'm done establishing identity number 1. Let's move on to number 2. Number 2, I've got the complicated side on the left. I think that happens on all 4 of these today. So, the first thing I see is that I have 2 terms, and on the other side I have 1 term. I want to bring that together. So again, common denominators. So I don't see anything, these aren't factors of each other, so I'm going to multiply them. Okay, so my first one will be the sine of theta times 1 plus the cosine of theta. And the second one will also be the sine of theta times 1 plus the cosine of theta. That's what my common denominator is going to be like. I'm not going to change the other side. I'm going to leave it. Try and leave yourself some room just in case we got to do the arrow and make a second column here. Now this first fraction I had to multiply by sine, so it's actually sine squared theta, right? To get that denominator to be sine times 1 plus cosine, I had to multiply by sine here, had to multiply by sine up here. Sine times sine is sine squared. Now this one already had the sine, so I have to multiply by 1 plus cosine theta. So this is going to be 1 plus cosine theta, and then it's times another 1 plus cosine of theta. Now that's not a plus and a minus, so that doesn't multiply out really nicely. It's going to be more complicated. It's going to get worse before it gets better. But at least I now have 1 denominator. And I'm not going to multiply out the stuff in the denominator because I think usually when this happens, something cancels. When you have 2 things times each other, something's going to cancel. And I see a 1 plus cosine up here, right? So let's combine this and just see what happens. And we'll see what happens later on. It's equal to 2 cosecant theta. Don't get lazy and stop writing that, by the way. Okay, so I have a sine squared theta up here from my first fraction. And if I multiply this out, I get 1 times 1 is 1, plus 1 times cosine is cosine theta. Cosine theta times 1 is another cosine of theta. And then there's a cosine squared theta. Okay. You don't see it yet, but I do, because I've seen this a million times. You guys know, don't you, that sine squared theta plus cosine squared theta is equal to 1. That's the Pythagorean identity, and that's hidden right here. Sine squared plus cosine, that's actually equal to 1. I can get those to turn into 1. Okay, so I'm gonna rewrite this, even though I already know what I'm going to do with it. I'm going to write the sine squared plus the cosine squared. I'll even put it in parentheses. That's going to turn into a 1. I'm just rewriting my numerator here. And then plus 1, and then plus 2 cosine theta. That's a cosine theta, that's another one that's 2. That's where that 2 probably came from. So in the bottom I have sine of theta times 1 plus the cosine of theta. Okay, I can see it. I see the rest of this problem being done. You may not, because you're new, but look, I've got a 1. And 1 plus 1 is 2. So this is going to be 2 plus 2 cosine theta. I will factor out the 2, and this will end up canceling, and this becomes cosecant in the top. I see it. We got to take it out step by step so you can see it. Okay, so I'm going to do this again. I'm going to go up to the top. That is 1, and this is 1. Hopefully you guys see that. That's 1, and this is 1. So I'm going to write 2 plus 2 cosine theta over sine of theta times 1 plus the cosine of theta is equal to 2 cosecant theta. Now that I'm here, I bet some of you are starting to see it. I don't know if you would have saw it right there, but I bet some of you are starting to see it. Some of you are probably still wondering, hey, where'd that 2 come from? Well, that 2 is this one, but when I replace this with a 1, I have 1 plus 1. That's where I got that 2. Okay, now I'm going to use the distributive property to factor that 2 out of there, and I get 1 plus cosine of theta left inside parentheses in the numerator. And I have sine of theta times 1 plus the cosine of theta left over in the denominator. Hopefully you guys see that something is about to cancel. This is in a grouping symbol in the numerator. It's in a grouping symbol in the denominator. There is no plus in between these things. It's all multiplication, so those cancel. And I get 2 over the sine of theta, and that's supposed to be equal to 2 cosecant theta, and it is, because sine is 1 over cosecant. So I can write 2 cosecant theta equals 2 cosecant theta. Now, you guys, this has got to feel an awful lot like doing a two-column geometry proof back in the day. The only difference is I'm not making you give the name of the theorem every time you go through. Your homework tonight is going to ask you what was the name of the last property you just used. So I'm just going to talk you through it. If I use the fact that sine is cosecant, those are reciprocals, aren't they? So I just use the reciprocal property. So my math lab's just going to ask you for the last one. Just be ready to think your way through. I don't want you memorizing anything. Just look at all the properties, names, and go, which one did I just use? Okay. Our third example, establish the identity. It's equal to 1. What that means to me is everything's about to cancel somehow. Everything. So I see tangent, cotangent, secant, and cosecant. Usually for me, guys, like I saw cosecant here, it means I'm going to flip something sooner or later. And look, we ended up with a sign in the bottom that gets turned. I'm going to write every one of these things as sine and cosine. On the top, I've got tangent. That's sine over cosine. I'm pretty sure that's going to get canceled out with this 1 over cosine or this 1 over sine. So here we go. Tangent is sine of v over cosine of v. And there's a plus. Cotangent is cosine of v over the sine of v. And I've got parentheses. Now I'm going to make these fractions also. 1 over the cosine of v times 1 over the sine of v. It's all got to be equal to 1. Okay. This I can write as one fraction. It's times each other, so I'm going to make it look a little cleaner. I would probably not write this step if I was doing this, and you won't either, but I'm going to write this one so you guys see what happens. Okay, I have the sine of v over the cosine of v in the top, and I have the cosine of v over the sine of v in the bottom, and what's really going on is I have 1 over the cosine of v times the sine of v. That's equal to 1. You see what I mean? I can put those as one fraction, so I can flip it and multiply. All right, here's what I get. Sine of v over cosine of v plus the cosine of v over the sine of v is all being multiplied. So I'm going to put that in a big old bracket or parentheses. It's getting multiplied by cosine of v, sine of v over 1. And of course, it's still equal to 1. I don't change that side. Now I'm going to distribute, and things are definitely going to cancel, and I'll be closer to having this being 1. Now there's a plus sign right here, so this has to get distributed to both of these. Okay, so I'm going to write it all out, and then you'll see what happens. So it is sine of v times both of these, times cosine of v times sine of v, and that's over this cosine of v. And there's my plus. So I took that, and I multiplied it by both of these, and I put it in the numerator. And then I have cosine of v is times both of these. So it's times cosine of v and times sine of v, and that's all over the sine of v. And this is apparently equal to 1. Okay, now that we got everything together and it's all one big party, we're going to cancel as much as we can. You ready for this? That cosine, since there's no plus or minus up in this numerator, that cosine could just straight up cancel with that cosine, leaving me sine squared. That should sound familiar. And then this sign in the bottom is going to cancel with one of these signs, so that becomes cosine squared. That should look familiar. So I'm going to go back up to the top again, and I'm going to write sine squared v. That's what's left over here. I'm going to put my plus, and I'm going to put cosine squared v. That's what's left after these signs cancel, is equal to 1, and that is definitely true. So I'm not going to hit check here because I didn't make the left side look like the right side yet. I'm actually going to use this and write this 1 in place of these. 1 is definitely equal to 1. Check. All right, guys, one last problem. I'm doing all this in one video today. Here we go. I've got two things that equal each other, and they look very similar. Like 1 minus sine over cosine, both of them are similarly difficult. You can choose either side. So we've been choosing the left side the whole time. I'm going to choose the right side just for fun. What I'm going to do is hint number 1. I think it was hint number 1 on the first page. Nope, the second one. I'm going to multiply by the conjugate. I see that there's a 1 minus sign and there's a 1 plus sign. It leads me to believe that multiplying by the conjugate is going to allow something to cancel. So look, I'm going to go 1 minus the sine of x over the cosine of x is equal to, and on this side, I'm going to multiply the top and the bottom by the conjugate, so it'll be times 1 minus the sine of x. Top and bottom, 1 minus the sine of x. It's just like multiplying by 1, right? It's an old trick from algebra, so I'm going to rewrite this one so it doesn't change. And then what I get on the bottom here, 1 times 1 is 1, and then look what happens. 1 times minus sine of x is minus sine of x. And 1 times plus sine of x is plus sine of x. They cancel. That always happens when you multiply conjugates. We've seen that before. So then this becomes minus sine squared x. And that should actually look familiar to you, that denominator. And on the top I have cosine of x, and it's times 1 minus sine of x. I am not going to distribute this because I see a 1 minus cosine over here. I'm going to try and see if I can get that cosine to cancel. I don't want to distribute it and make this top more complicated. I want that out of there. Now, the 1 minus sine squared you've seen before, okay? If sine squared x plus cosine squared x is actually equal to 1 in the Pythagorean identity, then this 1 minus sine squared can be found by subtracting. So cosine squared x is actually equal to 1 minus sine squared x. I can replace this denominator with that. That's pretty much going to put a cap on this thing. I'm going to be done in about 10 seconds here. So I've got cosine of x times 1 minus the sine of x, and what I'm going to write in place of this is that cosine squared, and you guys are going to see things cancel. That cosine cancels with one of those two. That's cosine times cosine, isn't it? So this cancels with that squared, and I get 1 minus the sine of x over cosine of x is actually equal to 1 minus the sine of x over cosine of x. Check. So I've got 8 of these for you guys to try in my math lab. And what my math lab does that's kind of nice is it doesn't just give you the beginning and the end. It takes you through steps. So you're going to have to follow what step did it do? How can I rewrite this step? And so it guides you through a little bit more. It doesn't just have you do the whole problem. Then I'm going to probably have to have you guys try some of these on your own so you write out the whole thing. All right. Have a good day, and we'll talk more tomorrow.